Recall L'Hopital's rule. And L'Hopital's rule is used to find the limit of indeterminate forms. And indeterminate forms are 0 over 0 type and infinite over infinite type. If you have one of those two forms, we can apply L'Hopital's rule. And the L'Hopital's rule stated the limit of f of x over g of x as x approaches a can be evaluated through the limit of the quotient of the derivative of those functions. Let's look at one of the examples. And when we're given a question or the limit of some function, and the first thing we need to do is we need to look into is this indeterminate form. So to look into that, and we need to mind the condition, which is as x approaches 0, look into e to the 0 minus e to the 0 minus 2 times 0 over 0 minus sine of 0. And e to the 0 is 1. And this is also 1, so I have 1 minus 1 as a 0 minus 0. I do have a 0 up top. At the bottom, I have a 0 minus sine of a 0 is 0, so I have a 0 at the bottom as well. I do have a 0 over 0 type, therefore I get to use L'Hopital's rule. And L'Hopital's rule stated, let's take the derivative for the top function and the bottom function. The derivative on top is e to the x minus e to the negative x, which is negative e to the negative x, minus 2 over the derivative of x, the derivative of a sine of x. I guess I'm going to simplify a little bit. E to the x minus negative as a plus e to the negative x minus 2, 1 minus cosine of x. So I'm going to check to see whether this function is still indeterminate form. So we have e to the 0 plus e to the 0 minus 2 over 1 minus cosine of a 0. Cosine of 0 is 1, so in the denominator, I do have 1 minus 1, which is 0. On top, we can see e to the 0 as 1, 1 plus 1 as 2, minus 2 is 0. I still have 0 over 0 type, therefore, I get to use L'Hopital's rule again. Again, it's about taking the derivative up top. I have e to the x minus e to the negative x minus 0, which is the derivative of 2. In the denominator, I have the derivative of 1 as 0. The derivative of cosine x is a negative sine, minus negative sine is a sine of x. Sine of x, sorry. And then we're going to look into, what about this function? It is an indeterminate form. And we are going to plug it in 0 for x again. I have e to the 0 minus e to the 0 over sine of 0. Sine of 0 is 0. 1 minus 1 up top, still 0. I still have a 0 over 0 type. I get to use the L'Hopital's rule again. And the L'Hopital's rule stated, let's take the derivative up top. The derivative of e to the negative x, again, remember, chain rule is going to be negative e to the negative x minus negative becomes plus e to the negative x over cosine of x. So what about this function? Is this still indeterminate form? We're going to look into, as x goes to 0, what's going on with this function. We'll have e to the 0 plus e to the 0 over cosine of 0. Cosine of 0 is 1. 1 plus 1 is 2 up top, so I have 2 over 1 is no longer indeterminate, and in fact, I just found the limit for this function. So we get to use the L'Hopital's rule as many times as necessary, means as long as the functions stay indeterminate, then I get to use L'Hopital's rule. Let's look at another example. And then remember we said first thing we got to do is we need to look into, do I have an indeterminate form as x approaches 0? Okay, so we are going to plug it in. 0 minus sine of 0 over cosine of 0. Sine of 0 is 0, cosine of 0 is 1. I have 0 over 1, which is 0. This is not indeterminate form. And here I actually found the limit for the function. If the function is not indeterminate form, we should not use L'Hopital rule. If you do, it's called misuse.